All right, product and quotient of complex numbers. These are kind of some nifty things that if you have, something in trig form instead of regular form.
This is why trig form is really great.
Yeah, because I want to throw this out here because it's been a while. Let's say that we have these two complex numbers that are in standard form. We call that standard form.
All right.
If we want to multiply...
Two separate numbers.
Yeah,
Okay.
yeah, that's why they have different
Right.
letters. If we want to figure out what these are multiplied together, we literally multiply them together.
You got to foil it out. Right.
Right? If you're going to multiply those, you have to foil. But if
Floy maybe, as it were.
If they were complex conjugates, which means the only thing different is the sign in front of I.
Right.
Right? Yeah. Then you might have a little easier time there. But for multiplying, you want to FOIL. If you were to divide those, so that'd be this situation.
Oh, stop.
No, we're going a little abstract here. You would have to multiply that by the complex conjugate.
Right, to clear out that denominator and make it a real number instead of a complex number.
Right. So if they ask you, and they will, if they ask you to divide from standard form, this is what we're talking about. So if these were actual numbers like 2 plus 3i over 5 minus 6i, you would change the sign on the bottom that's in front of I, so 5 plus 6i.
And the reason you multiply by the conjugate is because the i's will end up canceling out.
Right.
They go completely away in the denominator, and we have to have that because when you divide, you don't want there are no complex numbers in the denominator.
Right.
In a plus bi form.
Because I is basically a square root, and it's back to that idea of not wanting square roots in our denominators.
And so as you're looking over here on the right, this is quite a bit of work to multiply and divide.
So in fact, it may be simpler if you have the trig form already. You certainly don't want to change it.
No.
We just want to look at finding the product and finding the quotient. Here's how it goes. If we're multiplying some
complex number times another one.
Z1 times Z2. It gives you R1 times R2. You times the radiuses together and put it in front. You add the angles together.
Think about your exponential rules.
Right. When you're multiplying, it's like adding.
You add the exponents.
There's a connection there. So,
is it really?
Yeah.
Shut the door.
The front door?
Yes.
No.
Okay.
So
7 times 2.
7 times 2, that's our r's multiplied together.
And then it's just going to be, and now both angles have to be the same in both pieces. So if you put 25 plus 130 in the first guy,
it has to be the same.
You have to do the same thing in the second guy.
Yeah, they can't be different.
No, they can't be different at all. They must be the same.
The second angle can't be like, hey, I'm different, and then...
No, because we're talking about the same angle in both places.
So let's work this out real quick. 7 times 2 is 14.
Yes.
25 plus 130 is 155.
You got it.
And if we want to leave in trig form, this is our answer.
Yeah.
It asks us, though, to also write it in standard form.
So we'll do that.
Make sure you're in degree mode here.
So I got to change my, I got to get to degree mode. So you just finished writing.
All we're going to do here is distribute the 14, like we're going to do on the calculator, 14 cosine of 155 degrees. We'll write that down plus 14 sine 155, and then we'll put the I at the end.
Negative 12.688.
Okay, that's 14 cosine 155.
Oops, I forgot sine. Hold on, I hit cosine again.
That's just silly.
Jeez, big beefy thumbs. 5.917 I.
And the eyes have it.
I think we have it.
Okay, so that's
that guy.
That's it right there. If we're dividing, the difference is we divide the r's.
Oh,
when we were multiplying, we multiplied the r's.
When we're
dividing, we divide the r's
front door,
and we subtract the angles. So let's do that.
Let's keep it simple, stupid. The old KISS method, right?
Oh, that's an acronym.
An acronym.
That's totally. Yeah. I got that. 2/3
times,
because that's R1 over R2.
Now,
if we
subtract
could simplify,
the angles.
If we could simplify the 2/3, we would, but we can't here.
Right. Yeah. No. Correct. Like if it was like
4/6. Yeah.
Yes. Now we're going to have 30 minus 60, which is going to give us now the same angle in both. Yes, and order does matter because it puts us in a different quadrant if we get the order wrong.
Yes. Okay. So 30 minus 60 is negative 30 degrees.
Right.
And you can go ahead and type that in. You don't have to like try to do an angle-y conversion thing beforehand. We're doing cosine of negative 30, which that is actually on the unit circle.
Negative 0.866.
There's no negative there.
0.866.
Isn't
Also,
that square root of 3 over 2?
Might as well leave it at that. Leave it at that. Square root of 3 over 2.
Okay, well first, hang on. I'm getting ahead of myself. I have not written the trig form out. Cosine of negative 30 plus I sine negative 30. Okay, that's the trig form. That is one of our answers. And now we want to change it to standard form.
And we can't do this one without the calculator, actually. I was all excited. But
Yeah. So 2/3.
Hi.
And then cosine of negative 30
Cosine
was square root of 3 over 2.
Right.
And this would be negative 1/2.
Right. I.
Okay, and then we just distribute. So the 2's will cancel out, giving us square root of 3 over 3.
Minus.
The 2's cancel out, giving us 1/3.
1/3 I.
So that's it in standard form.
The I's have it.
Yes.